What would we see if we fell into a black hole? Ever wondered what it would be like to take a plunge into the ultimate cosmic abyss? Falling into a black hole is a mind-bending thought experiment that pushes the boundaries of our understanding of physics. Let's explore this fascinating, albeit fatal journey. Imagine watching someone fall into a black hole from a safe distance. The experience would be drastically different for you compared to the person falling in. Let's break down what you would observe. As the object approaches the event horizon, you'd see it appear to slow down. This is due to the extreme gravitational time dilation near the black hole. Time itself stretches and warps. The closer the object gets, the more pronounced this effect becomes. It's as if the object is moving in slow motion, struggling against the immense gravity. Light emitted from the falling object would become increasingly red-shifted. This means the light waves are stretched, shifting towards the red end of the spectrum. Simultaneously, the object would appear dimmer and dimmer. The energy of the light is being sapped as it fights against the black hole's gravity. Eventually, the object would seem to freeze at the event horizon. It would appear stuck, never quite crossing the boundary. The image would become infinitely faint and red-shifted, almost disappearing from view. It's as if the object is fading out of existence. From your perspective, the object never actually crosses the event horizon. Time slows down infinitely as it approaches. The object remains forever on the edge, a ghostly image frozen in time. This is a consequence of the extreme warping of space-time. Now let's shift our perspective and imagine what it would be like to be the one falling into the black hole. The experience is far more dramatic and unsettling. Let's assume you're falling into a supermassive black hole. These behemoths have weaker tidal forces at their event horizons compared to smaller black holes. This means you might not be immediately ripped apart upon crossing the event horizon, at least not right away. As you approach the black hole, the universe outside becomes increasingly distorted. Light bends and warps around the massive object. Light from the outside world is compressed into a bright, shrinking spot ahead. It's like looking through a cosmic magnifying glass. The black hole's gravity bends light from all directions, creating bizarre visual effects. The familiar constellations would be unrecognizable. Crossing the event horizon is the point of no return. Once you're inside, there's no escape. No communication with the outside universe is possible. You're cut off from everything you once knew. The singularity, an infinitely dense point at the center of the black hole, becomes your inevitable destination. There is no turning back. Even with a supermassive black hole, your journey won't be pleasant. Tidal forces will eventually become overwhelming. Tidal forces are the difference in gravitational pull on different parts of your body. These forces become incredibly strong as you approach the singularity. You'll be stretched lengthwise and compressed sideways. This is the beginning of a process known as spaghettification. As the tidal forces intensify, you'll be elongated into a long, thin strand of matter. You'll literally be stretched like spaghetti. Your body will be torn apart at the atomic level. The experience would be unimaginably painful and disorienting. Smaller black holes have stronger tidal forces closer to the event horizon. This means spaghettification occurs sooner for smaller black holes. You might be ripped apart long before you even reach the event horizon of a smaller black hole. Size truly matters in this cosmic scenario. What happens when you finally reach the singularity? This is where things get truly mysterious and speculative. What happens at the singularity is largely unknown. Our current understanding of physics breaks down at this point. General relativity predicts the existence of singularities, but it doesn't tell us what happens inside them. We simply don't have the tools to probe this realm. One possibility is that you're crushed into an infinitely small point. All your matter and energy are compressed into a single dimensionless location. Another, more speculative idea is that you might enter another universe. Black holes could potentially be gateways to other dimensions or realities. Some theories even suggest the possibility of entering a white hole, a theoretical opposite of a black hole. White holes are thought to spew out matter and energy. These possibilities are highly speculative. They are based on theoretical models and mathematical equations. We currently lack any observational evidence to support these ideas. The singularity remains one of the biggest mysteries in physics. Falling into a black hole is a one-way trip into the unknown. It's a journey that challenges our understanding of space, time, and the very fabric of reality. From the perspective of a distant observer, you would freeze and fade at the event horizon. But for the falling object, it's a tale of distortion, spaghettification, and a final encounter with the singularity. The encounter with the singularity remains beyond our current scientific understanding. It's a realm where the laws of physics as we know them cease to apply. Ready to delve deeper into the mysteries of the universe? Subscribe to our channel for more mind-blowing explorations of space and physics. Don't forget to like this video and share it with your fellow space enthusiasts. And tell us in the comments, what other cosmic questions keep you up at night?